Mastering sampling error calculation. Sampling error can sabotage your data-driven decisions. Why is it essential to understand the definition of sampling error in the context of operational excellence, which refers to the deviation of a sample statistic from the true population parameter, and how does it impact the accuracy of our data-driven decisions? In the pursuit of operational excellence, it is crucial to comprehend the concept of sampling error and its implications on data-driven decision-making. Sampling error, defined as the deviation of a sample statistic from the true population parameter, is an inherent aspect of statistical analysis. This error arises when a sample is used to represent an entire population, and its magnitude depends on various factors, including sample size, sampling method, and population variability. There are two primary types of sampling errors: random sampling error and non-random sampling error. Random sampling error occurs due to chance variations in the sample selection process, whereas non-random sampling error results from systematic biases in the sampling method. The former can be minimized by increasing the sample size, while the latter requires careful attention to sampling design and execution. The impact of sampling error on operational excellence is multifaceted. Firstly, it can lead to inaccurate or misleading conclusions, which can have detrimental effects on decision-making. For instance, if a company relies on a sample of customer feedback to inform product development, a sampling error could result in the misidentification of customer needs, ultimately leading to product failures. Similarly, in quality control, sampling errors can lead to incorrect assessments of process performance, resulting in inefficient resource allocation and compromised product quality. Sampling errors can also undermine the credibility of data-driven decision-making. When stakeholders perceive that data is unreliable or inaccurate, they are less likely to trust the decisions based on that data. This erosion of trust can have long-term consequences, including decreased collaboration, increased skepticism, and ultimately, decreased organizational performance. Furthermore, sampling errors can lead to unnecessary variability in process performance. When sampling errors are present, process control limits may be misestimated, resulting in incorrect signals for improvement or troubleshooting. This, in turn, can lead to unnecessary adjustments, wasted resources, and decreased overall efficiency. To mitigate the effects of sampling error, it is essential to implement robust sampling strategies and statistical analysis techniques. These may include: 1. Increasing sample size. Larger samples generally provide more accurate estimates of population parameters, reducing the sampling error. 2. Stratified sampling. Dividing the population into homogeneous subgroups and sampling from each stratum can improve the representativeness of the sample. 3. Systematic sampling. Selecting every nth element from a list or sequence can reduce the impact of sampling error. 4. Data validation and cleaning. Ensuring data quality and removing errors or inconsistencies can reduce the impact of sampling error. 5. Using multiple samples. Analyzing multiple samples can provide a more comprehensive understanding of the population, reducing the reliance on a single sample. In addition to these strategies, organizations can benefit from adopting a culture of continuous improvement, where data-driven decision-making is encouraged, and the limitations of sampling error are acknowledged and addressed. This includes: 1. Training and education. Educating stakeholders on the principles of statistical analysis and the implications of sampling error can foster a culture of data literacy. 2. Transparency and communication. Openly discussing the limitations of data and the potential for sampling error can promote trust and collaboration. 3. Ongoing monitoring and evaluation. Continuously assessing and refining sampling strategies and statistical analysis techniques can ensure that data-driven decision-making remains accurate and reliable. In conclusion, understanding sampling error is crucial for achieving operational excellence. By recognizing the sources and implications of sampling error, organizations can take proactive steps to minimize its impact, ensuring that data-driven decisions are accurate, reliable, and trustworthy. By adopting robust sampling strategies, statistical analysis techniques, and a culture of continuous improvement, organizations can unlock the full potential of data-driven decision-making and drive operational excellence.